All right, what is up, guys? Got to kick off Chapter 7 on our glorious e-learning day. All right, so this one should be a little bit of a respite from all the antiderivative stuff of Unit 6 and a quick break before Unit 8. All right, we'll cross that bridge when we get there. We're just going to do Unit 7, okay? All right. So Unit 7 is all about what are called differential equations. Differential equations. So differential equations, all they do is they relate a function to its derivatives, okay? To its derivatives, to some set of its derivatives, right? So actually engineers love these too. Engineers absolutely love differential equations, right? Because what they'll do is, so you can see this first equation here, right? This says that if you take a function y, you take its first derivative, take its second derivative, okay? If you add the second derivative to twice the first derivative, you get 3 times the original function, okay? So a lot of times what engineers will do is they'll come across a situation like a word problem. That's basically what engineering is. It's just professional word probleming, okay? They'll come across a problem and they'll be able to use the details of what's going on in the situation to write down a differential equation pretty easily, okay? And then the whole difficulty for them is solving. A lot of times what we do with differential equations is we solve for the function given this equation. If we are given an equation relating a function to its derivatives, we can then solve and figure out what the original function is, okay? And then we can use that and program that into whatever, and yeah, okay. Example 1, okay? All right, so this example is going to touch upon how we this is not solving a differential equation. We're just trying to pull our differential equation out of this word problem, okay? So particle moves along a straight line. Its velocity v is inversely proportional to the square of the distance it has traveled, okay? Velocity is inversely proportional to the square. So inversely proportional means, right, it equals 1 over the thing. So it's going to be 1 over s, and not just 1 over s, right? It's inversely proportional to the square of the distance, s. So it's going to be proportional to 1 over s squared. Okay, so it's going to be just equal to a constant times that. Okay, so v equals k over s squared. Cool. That's actually not a differential equation, okay? I think it's trying to draw a distinction, okay? All right. Cool, yep, so this is just this paragraph here is just a little discussion of direct versus inverse variation. So if I have a variable a that's directly proportional to another variable b, then I know that a equals some number k times b. If a is inversely proportional to b, then a equals some number k divided by b. Okay, there you go. All right, example 2, a puppy gains weight at a rate approximately inversely proportional to its age, t in months, okay? Write an equation that describes this relationship, okay? So it talks about the puppy's weight, w, okay? They mentioned that, right? But what did they actually describe? They said the rate at which the puppy gains weight is inversely proportional to its age, okay? So we're going to have something inversely proportional to age, so it's going to be some k divided by t, all right? All right, and instead of writing w there on the left, I'm going to write the first derivative of w, all right? Because this paragraph here does not describe how the weight changes. Okay, it doesn't describe the weight. It says the rate at which the puppy gains weight. It talks about the rate. So that's how we need to do the first derivative on the left. Example 3, the learning rate for a skill. Okay, again, the learning rate for a skill. Okay, so that's that's how the skill changes over time, and it's proportional to the difference between the maximum potential learning that skill, m, and the amount of that skill already learned. So it's proportional to this difference. So it's going to be k, some number k times that difference. Okay. Example 4, an IV drip administers medication to a patient's bloodstream at a rate of 3 cubic meters centimeters per hour. All right. So IV drip is giving us 3 cubic centimeters per hour. Okay. At the same time, the patient's organs are removing the meds from the patient's bloodstream at a rate proportional to the current volume of medication in the bloodstream. Which equation describes this relationship? All right, this one's a little more in-depth. Okay, so let's think about this. All right, so they're talking about the rate, right? So the total change, right? So the current volume of medication, right? The change of that, right? That's going to be the amount in minus the amount out, right? The change, right? So V is the amount of medicine in the patient's blood. So the derivative of that is going to be how the amount of medicine in the patient's blood is changing over time. And they're saying that, right? So that's going to be equal to the amount in minus the amount out, okay? So what's the rate that it's entering at? It's entering at 3, right? The amount in is 3 cubic centimeters per hour. And they're removing the meds at a rate proportional, so K times V to the current volume of medication. So dV dt equals 3 minus KV. There you go. A is your answer, okay? So it's just breaking down word problems. Example 5. Let's think about this, okay? As you read this word problem, think what's my rate in and what's my rate out. So a chemical is diluted out of a tank by pumping pure water into the tank and pumping the existing solution out of it. So the volume at any time t is 20 plus 2t, okay? So what they're saying is the volume of liquid, okay? So the concentration of the liquid is always changing, right? But the amount of liquid total is always the same, right? Okay? It's just the only thing that's changing is not the volume of the tank, the amount of liquid in the tank, it's just the concentration of it. So the amount of chemical Z in the tank decreases at a rate proportional to Z and inversely proportional to the volume of solution in the tank, which this equation describes this relationship, okay? So let's think of this. The amount of chemical Z in the tank, it decreases at a rate, right? So they use the word rate there. So the rate of change of Z, so Z is the amount of chemical in the tank. The rate of change of Z as time goes on, right? It's decreasing, so it's going to be negative. It's proportional to Z, right? And inversely proportional to the amount of liquid in the tank, okay? There you go. That's it. There you go. So inversely proportional to the liquid, so I divide by the volume of liquid, right? And we're directly proportional to Z. If it says proportional and it doesn't say inversely proportional, that's an implied directly proportional. All right, we're decreasing, so we get the minus sign here. So the answer to that is A. All right, so that's it for 7.1. Hopefully that's a pretty chill lesson for you guys. Let's move on to 7.2, okay? So this is about verifying solutions to differential equations, okay? So we have a differential equation here. Why is it a differential equation? It relates a function f to its second derivative, okay? Whenever a function appears in the same equation as one or more of its derivatives, that's what we call a differential equation, okay? So we want to verify whether each of these solutions satisfies this differential equation. So what we have to do, right? We have f of x, we got to find f double prime of x first, okay? Right? And then if f double prime, if we subtract f double prime minus f, and it gives us 0, then we'll know that the given function does indeed solve this differential equation. So let's do f prime of x. That's going to be, in this first example, it's going to be cosine x. F double prime is going to be minus sine, okay? So if we do, let's plug that into our equation, okay? So it's going to be minus sine x, just plug in f double prime here, minus sine of x, right? That's going to be, negative 2 sine x, which in general is not equal to 0. So no, our answer is no. It does not satisfy the equation. Let's move on to B. First, let's do f prime of x. It's going to be negative 4e to the negative x. F double prime of x is going to be 4e to the negative x. All right, so just chain rule, okay? And then f double prime of x minus f of x. Let's just plug in what we found on this line and then what they gave us in the original equation, right? We're plugging in the yellow stuff for f of x, plug in the pink stuff for f double prime of x, okay? That's going to be equal to 4e to the minus x minus 4e to the minus x. A number minus itself is 0, so yes, it does solve the differential equation. All right, C, part C. F prime of x is going to be c e to the x. F double prime of x is going to be c e to the x. So f double prime minus f is going to be c e to the x minus c e to the x, which a number minus itself is 0. So yes, it does solve the differential equation, okay? So I'm literally just taking the second derivative and plugging the second derivative in the original function that it gave me in the problem into this equation, see if it equals 0. If it equals 0, I write yes. If it doesn't equal 0, I write no. Okay, that's it. Ooh, fun. Okay? We want to see if these two functions solve this differential equation. dy dx equals 4y over x. So let's do that. So we just have to do dy dx, right? That's just the derivative of y. So the derivative of y is going to be 4. And let's plug stuff in, okay? So I'm going to plug the pink stuff in for dy dx. So I'm going to have 4 equals, and then what I'm going to do, I'm going to plug in my original function they gave me for y. So on the y line here, when I'm just going to plug 4x in for y because the problem tells me that y equals 4x. So I'm going to have equals 4 times 4x, and then all over x. Just copy that down. All over x. All right, let's see if it satisfies, okay? The x's cancel out. I get 4 equals 16, which is not true. So no. The given function does not solve the differential equation, okay? Let's do B, okay? So dy dx. We got to find that dy dx just by taking the derivative, okay? So we get 4x cubed, right? Plugging that in for dy dx equals 4 times. Let's plug in my y. My problem says that y equals x to the 4th. And we have our divide by x. That's going to be x to the 4th over x is just x cubed. This is true. This is always true. So yes, my function does solve the differential equation, okay? So a differential equation, right, instead of plugging a number in to check, we plug a whole function in and its derivatives, okay? There we go. For what values of k, if any, is y equals e to the 2x plus k e to the negative 3x a solution to this big old differential equation here, okay? So we need to plug in, to check, right, we start with y, right? Into this equation, we need to plug y and y double prime, okay? So let's do that, okay? So we're gonna have, so let's compute y double prime. So y prime is 2e to the 2x minus 3k e to the, what, negative 3x? Yeah. And then y double prime is 4e to the 2x plus 9k e to the negative 3x, okay? So let's plug in y, and let's plug in y double prime to my equation, okay? We'll get 4 times e to the 2x plus k e to the negative 3x, right? That's just my y. Okay. Minus y double prime, that's going to be 4e to the 2x, right? That's just that line right above what I'm working on. Then that equals 10e to the negative 3x. I'm going to color that out in white. I'm sorry. I got to get rid of that 3 page numbers. There we go. All right. So let's distribute and combine everything, okay? So let's distribute the 4. Distribute the negative. All right, let's combine our like terms. These two are going to cancel. The other two terms on the left there are going to combine, right? So we're going to have negative 9k e to the negative 3x and positive 4k e to the 3x. Those are going to combine to negative 5k e to the negative 3x. Sorry, that should be an x. Should be an x, sorry.
What's that?
Hey, Kathy. All right, and then I'm just going to divide both sides by e to the negative 3x. All right, just going to get k by itself. We're solving for k. So I get negative 5k equals 10, or k equals negative 2. There you go. A. Good. All right. Let's do the 7.2 skill builder for Friday. Take care, guys. Thank you.